In LAB4, we're connecting an external LED to the FRDMK64. When you look at any particular LED, you're going to find that there's a longer leg and a shorter leg. The longer leg is the anode or positive side, and the shorter leg is the cathode or the negative side. And current's going to flow from positive through here to negative, and we have to be aware of that once we start hooking it up. Also, besides being the shorter leg, you'll find that on the casing here, there's a flat edge here that also indicates the cathode. This becomes useful when you start cutting off the legs and trying to fit them into a breadboard to make sure that you know which one is the cathode by the flat edge here on the casing. Now, as I said, in LAB4, we're going to be asked to connect a blue LED to port C pin 16. And there's two ways to connect this up. One is have PT16 going into the LED on the positive side here. And on the negative side or cathode, we're going to have a resistor of 220 ohms going to ground. And with this setup here, if you have 3.3 or 1 here, it's going to be on. And if you have 0 volts coming here, it's going to be off. Now, there's another way to actually hook up PTC16 to a LED, and that's to have VCC, which is 3.3 volts coming through here, to a 220 ohm resistor to PT16. And therefore, if you have 3.3 volts here and 3.3 volts here, it's going to be off. So 1 is off and a 0 is on. This is the way the RGB LEDs are hooked up in this fashion here. But for our purposes here, we're going to use this format here, where we're going to have 1 turning it on and a 0 shutting it off. Now, if you look at this diagram of the FRDMK64, we're going to hook one end to ground, which is going to be our cathode, and then we're going to hook up here PTC16, which is this pin here, to the positive side of the LED. So as you can see here, this is our ground pin here, and it's going all the way over here to the other side of the resistor here, which is our 220. So that's our ground. And this one here is going to be PTC16, which is going to go to the anode side here. So the anode across to the cathode to one end of the 220 ohm resistor, and then back to ground here completes the entire circuit. Even though it is possible to make PTC16 output and send high and low values to the blue LED using the memory browser, one thing you have to do first, select PT16 to be the thing connected, because there's so many different things connected and they're multiplexed. So we're going to have to use the pins tool to select that first, and then we can do that using these registers here. So we're going to demonstrate that in the video that's going to follow. Now at this point, what we want to do is we want to make a new revision. So we're going to right mouse click, we're going to say copy, we're going to go up here and right mouse click and say paste. And instead of saying IRQ2, we're going to say _rev1. Once we've got that, we're going to close the old one, and then we're going to go up here, and we've got our code that we're going to start working with here. Now that we've closed it, we can also go right mouse click here and say delete, and make sure we don't select that, but take it out of our workspace. We're just working with this. The next thing we have to do with this new revision here is we want to go up and go to the pins tool. And what we have to do is go to PTC16, which is this pin here, click on it. And we have to specify that as GPIO. And once you do and put it here, you can say done. Now, one of the things that you can do here is go in here and change this to output, but we can do that using the memory browser. We'll see how that works, and then we'll come back here later and actually change this to output to make sure we update it. Now, what we should do here is update our code and say OK. Next thing we want to do is actually just hit debug so everything is going to work properly. And we're just going to say OK, and we're going to download it to the board. Once we've done this, then we're going to have our proper X file set up, so our pins are set up properly, so we know that it's PT16 coming out there. And notice up here we've got this LAB4 2 button whatever debug launch, and we've got rev1. So let's get rid of this one here and say delete, say OK. And the next step is we want to go to our memory browser. Now at this point, we've just gone into the debug, we've downloaded our code, we've got address 40F080 here, which we need. And then what we're going to do is step over our boot init pins, and we can see that things have changed up in here. Now, because we didn't set the data direction register here, we're going to have to do that first. That's address 400F094, which is this address here. Now, port 16 is 00010000. That's where that PTC16 is right there. And once we've got that, we should be able to use the toggle register, which is 8C. Let's go to 8C, and we can put in 0001, 0000, and indeed the blue LED comes on. And if we want to go back to 8C again, we can go 0001, 0000, and the LED goes off. So it's very important that we set the data direction register first before we can do this. Now at this point, let's go back to our pins tool. And we will actually set this now by clicking on it to output, close, and update code so everything is going to work properly. And then you should be able to finish off LAB4 by putting in the appropriate responses that it asks for here. We've set our routing details. We're at the bottom of page 8, starting on to page 9 of 12. And we've actually set it to be output and a logic 0 because turning it off is a logic 0 and 1 is turning it on. Now in step 7 here, we're going to have to add this line of code to our SW2 ISR and this line of code here to our SW3 ISR. Now that we've made this change here to the SW2 ISR and the SW3 ISR, it's time to go to step 9 of our lab. Now in step 9 it says include these new printf statements in main of the source code, which will print the following things. We've already got this, but we're changing the press SW2 to a little longer line here and SW3 the same. We're also adding a system status disarmed. Now we're going to have system status armed in the SW2. In our service routine, we're going to have this system status disarmed every time the SW3 happens. Now this time when you run your code, you're going to see these messages show up. And when we push our right push button, we're going to see the red LED coming on and the message coming up that says system status armed. And we're also going to see the blue LED come on. When we press the left push button, the red light's going to go off, the blue light's going to go off, and it's going to say on the screen, system status disarmed. That's what you're going to get when you press this and press that.